chết hết rồi. Dưới đây là cái thằng qua hết mà có cái đồ đấy
Xin lỗi các bạn, cái này cái ông technician của trường này nó mới chọc máy này, không biết làm sao nó không lên. Để tránh cái giờ mất 5 phút rồi. Bắt đầu luôn này. That is my habit that before any new class, I always make a review of what we studied last week. And so please, we look at the screen on the two sides, not in front of you. Last week we studied a system of linear equation. Like that. Okay, so we have a system of linear equation. I will go very fast. That is a system of n linear equation in n variable. We have the notion of coefficients, coefficient AI, A1, A2 up to AN, and the unknown of the variable is x1 up to xn. And the right hand side will be b1, b2 up to bn. So the number of equation and the number of variable is quite different from each other. And for a system of linear equation, we have only two cases. The first one, the system is consistent. It has at least one solution. And it is inconsistent. It means that the system has no solution. Then I explain to you that for suppose that you are given a system of linear equations, then you can have only one of three possibilities. The first one, it has only one solution. The second, you have infinitely many solutions. And the last one is you have no solution. Only three. Then, in order to solve the system of linear equation, we use the so-called elimination of invariance phương pháp khử. So, in order to do elimination, we apply one of three operations. Then, we can change any system of linear equation into a new system of linear equation having the same system, the same solution set, and three operations we are applying. That is, the first one, we interchange two equations. The second operation, that is, we multiply both sides of an equation by a non-zero constant. The last operation, that is, we add k times of an equation to another equation. That is three operation we apply in doing eliminating to solve the system of linear equation. Then the next we study the matrix. We change anything into the matrix language to simplify our way of writing, to simplify our kind of solving the system of linear equation. So now, now we have it here. So given a system of m equation in every region like that, in matrix form we can write in only one single equation like it here. And here in that form, A2 is a matrix like that. That is a coefficient matrix of the system. And X is a columns matrix of unknown. And B is a column matrix of right hand side of the system. And besides the coefficient matrix A, we have a new notion, new definition, that is a O-matrix matrix, or in Vietnamese matrix. So that is together with the coefficient matrix, we add one more column on the right hand side. That is, we take the column of right hand side of equation to write it on the right of the matrix A. You get that one. Then for a matrix, we can have three kinds of row operation. We call it row elementary row operation, and it is exactly the same operation like we applying in eliminating a system of linear equation. The first one is interchange two rows, denoted by that thing. That is, we interchange the i's row and the j's row. The second operation, we multiply on entry on rows by a non-zero constant is here. We multiply on entry on the i's row by the number k. We get a new i's row. And the last one, we add multiple times of a row to another row. It is here. So in last class, we have a lot of examples to see how we can apply those operations. Then two matrices is considered to be row equivalent if one of matrix can be obtained from the other by applying a finite sequence of those operations. Now, the next slide shows you how we can use matrix to simplify writing the procedure to solve a system of linear equation. Suppose that we are given a linear system like that one. And we write down, first we write down the matrix which is here. Then, the first step, we apply that operation. It means that we add the first row to the second row. We get a new second row. And the reason is here. And at the same time, if we add two sides of the first equation to the second equation, you get that one. That is that operation applying for the system, you get that one. Or if you apply that for the matrix, you get that one. We continue with this one. We apply that one. The system becomes that, and the matrix becomes that one. And finally, you get that, you continue, and finally, you get that thing. And that is very special form of the matrix, is a very special form of the system of linear equation. From here, it's very easy for you to find the solution. But I would like to stop at here because the special form of matrix is here, and it leads to the notion of the row echelon form is here. A matrix is a set of row echelon form if it satisfies the condition number 1, 2, and 3, like it here. And a matrix is of reduced row echelon form if it satisfies not only 3 conditions but also one more condition, number 4, that is here. Every column containing the leading one must have 0 above and below the leading one. So I will not read the condition here. You need to know it already, but I repeat for you only a matrix of row echelon form satisfies 3 conditions and reduced row echelon form must satisfy 4 conditions. And the example is here. The example is much easier for you to see what is a row echelon form and what is a reduced row echelon form. And especially, I call your attention to the last two to see that which one is not in the row echelon form. Then, with the notion of row echelon form, with the notion of row, everyday row operation, now we can write down what is Gaussian elimination and Gauss-Jordan elimination. The Gaussian elimination is the procedure to reduce any matrix into row echelon form. And Gauss-Jordan is a procedure to reduce any matrix to reduce row echelon form. So from Gaussian elimination to Gauss-Jordan elimination, we need to do just a little more calculation. And the remark, once again, I want to insist here that is, every matrix has only one reduced row echelon form, but it has several different row echelon form. The last about the system of linear equation, that is about system about the homogeneous system of linear equation. By homogeneous, I mean on the right hand side of equation at 0. So for that, you know that the system has always a solution x1 equal x2 equal xn equal 0. That has named trivial solution here. And we have, obviously, for a homogeneous system of linear equation, we pay attention to find non-trivial solution. That is any other solution than x1, x2, xn equals 0. So that is a finish of the lecture number 1. Then we continue with the lecture number 2. Lecture number 2 about the matrix operation. That is operation on the matrix. And in matrix is a rectangular table like that. We have a special form of matrix, that is diagonal matrix. Looks like that on the screen. And in order to define the first operation, that is addition, factor, we need first to define two matrices equal each other. Two matrices A and B can be considered equal each other if they are of the same size, the same number of rows, the same number of columns, and corresponding entry must be equal each other. It is here. And then, whenever we have that, we can define the matrix addition factor. I mentioned. we can add two matrices A and B if and only if A and B are of the same sign. Then A plus B equals that. The sum is a new matrix. The new matrix of the same sign like A and B, and the corresponding entry equals the sum of corresponding entry of A and corresponding entry of B. An example is here for you to be easy imagine how we can define it. Then the next operation is scalar multiplication. We multiply on the entry of a matrix by a number k, and the matrix subtraction factor. The matrix subtraction is defined like that. The last one and the most difficult operation is matrix multiplication, and I don't like to insist on that because today we quote on that one. We can multiply two matrices A and B with a very special sign like that one. The number of columns of A must equal the number of rows of B. It is here. And the product has a very special sign. Sign of the product is the number of rows equals the number of rows of A, and the number of columns of the product is the number of columns of B. Is here. And it is very difficult to remember the Cij, the entry Cij. It is given by a rather complicated formula like that. But however, if you look at the picture here, now you can easily remember what is the Cij here. And the remark saying that for the addition we have a commutativity. Với phép cộng chúng ta có tính giao hoán, but that is not for the multiplication. Phép nhân mà trận không có tính giao hoán. And today we will see about that one. So that is the end of the review, and that is on what we studied last week. And today we will continue from that point.
Water nó happy.
So once again I repeat for you the examples. Now suppose that we are given two matrices like that, and the sign of A and B like that allow us to multiply them together. And the reason is like that. If we multiply A to B, you get that one. And how we can get that and that? It is as follows. We take the first column, the first row of A, the first column of B, multiply corresponding entry, we get that one. And if we take the second row of A, second columns of B, we get that number. And that is the way we multiply two matrices A and B together. Now I am going to explain to you last week I tell you that given a system of linear equation like that, we have so many line of equation, but now we can write it in only one single matrix equation. But how we can do it? It is here. You see, that is M linear equation. But now we change it into that one. you see now the coefficient matrix became that the big here A, and the columns of unknown is here. Then two matrices can multiply each other by this way. Then if you multiply the first column here, the first row here and that column, you get the right hand side of that equation. If we take the second row here and multiply by the column of unknown here, you get the left hand side of the second equation here. And because that must equal the matrix here, so that multiplied by that must equal B1. So we get the first equation. So it means, it want to say to you that when you write it in this form, that is exactly the multiplication of matrices. The matrix, the coefficient matrix and the matrix of unknown. And here, if we count the first one, A denoted by A and denoted by that by X and that by B, then M linear equation now became only one single matrix equation. Is here. Ax equal B. Now the equation has meaning behind it. The meaning, that is, we take two matrices, we multiply them together, we get the column matrix of right hand side B here. So, so far we study C operation of matrix. The first one is addition. The second one is scalar multiplication, and the last one is matrix multiplication, CT. See, you have two more operations, but however, we stop here. Now we consider the property of that. The property of that. You know that in high school when you study operation on numbers, you have some property of that. Ở phổ thông khi các bạn học các phép toán sin số, các bạn cũng sẽ có các tính chất giao hoán, tính chất kết hợp gì đó. We are going to have similar things here. Now, first we got two special kind of matrices. The first one has been zero matrix. That is a matrix of any size n by n, having on entry being zero, like that. That is the first special matrix. The second matrix is identity matrix. The identity matrix of order n, that is a square matrix of order n. And more than that, it must be a diagonal. Any entry outside of main diagonal are zero, and on entry lying on the diagonal must be 1. With that, the matrix which has made identity matrix of order n. In Vietnamese, you have ma trận đơn vị n. Next, now we consider the property of matrix addition and of scalar multiplication. First, about the addition, we have a commutativity, có tính giao hoán. A plus B equal B plus A. Very easy for you to verify it. Second one, that is associativity, tính kết hợp. A plus, if you first you add B and C and then add to A, that equals first you add A to B and then you add that to C. Obviously, in that case, A, B and C must be of the same sign, otherwise you cannot add them together. The property number 3 saying that if you take two numbers C and D, first you multiply two numbers together, you get the product C and D. And take that number, multiply with the matrix A is equal. That first you multiply D to A and then you multiply C to the product DA. That's the same thing. The next one saying if you take the number 1 multiplied by matrix A, nothing change. You get A again. Property number 5, that is if you multiply a number C by the sum of two matrices A and B, it equals C multiplied by A plus C multiplied by B. And the last one, now we exchange the role. Now we take two numbers C and D. First we add them together like two numbers, cộng hai số C and D together, we get a new number. You take that number multiplied by matrix A, that equals, first you multiply C by A and then D by A and then you add them together. So that is the sixth property for addition. Now about the scalar multiplication, you have the following. Oh, that is already about the scalar multiplication. Now we have a property for zero matrix. Suppose that A is any matrix n by n. C is a number. Then we have the following. If you take A and you add them to the zero matrix, nothing changes. Nothing changes. If you take A plus minus A, you always get zeros matrix. And the last one, suppose that you take a number C multiplied by matrix A equal 0. The reason you get is a zero matrix. Then you can have only one of two following possibilities. The first one, C must be the number 0. And the second one, A is 0 matrix. You can have no other possibility, only one of the possibility. So, that property will give you some name. The first property here says that the zero matrix is additive identity for the set of all n by n matrices. That is identity of the addition. And in Vietnamese, mã trận không là đơn vị của phép cộng. The second one, second property says that minus A is additive inverse of A. It means that A minus A is inverse of addition. Trừ A là phần tử ngược của phép cộng hay là phần tử đảo nghịch đảo của phép cộng. However, that is just only some name, you can forget it for the moment. Now, that one is very important and you need to remember because you are going to do with this later. Now, that is a property of identity matrix, tính chất của mã trận đơn vị. Suppose that A is a square matrix order n, and IN is an identity matrix of the same order. Then you will have A by n by in equals in multiplied by a equal a. It means that if you take the square matrix of order n multiplied by an identity on the right side or on the left side, nothing changes. You always receive the matrix A, nothing changes. That you can verify by definition of matrix multiplication and by definition of the identity matrix. Now, the difficult part of the operation, that is matrix multiplication, phép nhân các ma trận. So what is the property of matrix multiplication? The first one we have A multiplied by B by C equals that. That is the associativity, tính kết hợp. Phép nhân các ma trận có tính chất kết hợp. However, you should remember that the side of A, B, and C must be very special so that we can multiply them together. The second one is A multiplied by B plus C equal A multiplied by B plus A multiplied by C. That property has been distributivity, tính phân phối. And the property number 3 as the same like number 2, but only we change from the left side to the right side. Again, the property has been distributivity, but however, we can say that the property is distributivity from the left, from the right. Property number 4 saying that if we take a number C multiplied by the product of two matrices A and B, it equals that C, we take C multiplied by one of matrix C multiplied by A and Z multiplied by B, and also it equals A multiplied by C and Z multiplied by B. And the last property saying that matrix multiplication does not have commutativity. Phép nhân ma trận không có tính giao hòa. Why that? We are going to explain that later, but now we continue one more operation. But that operation is very, very easy to see. That is the transpose of a matrix. In Vietnamese is chuyển. Chuyển, that is chuyển. Vị means vị trí. So it is very, very easy to see. Given a matrix A like that, we change rows into column, column into rows. That is transpose. And it is here. Then transpose of A denoted by A to the power T is like that. And you see, we take the first row of A, when we move it into the first column of A, T. Take the second rows, now it becomes the second columns of A, T, and so on. We do it up to the last columns. The last row of A now becomes the last columns of A, T. So that is transpose. So that is very easy, not like a matrix multiplication. And here is an example, very easy for you to see. A, B, and C like that, then you are required to find transpose, then AT to be that. So here you see, if you are given a columns matrix, then it transpose will be row matrix. And in the converse, if you are given a row matrix, you take the transpose, you will get the column matrix. The next one, A to be that, then AT will be that one. And the last one, C to be that, then AT will be that one. So that operation is very easy to compute. And property of transpose. The first one also very easy to verify. If you take transpose and then take transpose once again, you go back to the original one. First row into column and then column again into row, so nothing changes. The next one, if you take transpose of a sum of A and B is equals A transpose plus B transpose. And if you take scalar multiplication of A and then transpose, then it equals C multiplied by A transpose. Why that? Because the number C, you don't have any transpose of a number. And the last one, you should pay attention to. If you take A, B, and then transpose, it equals B transpose multiplied by A transpose. That is why I say you should pay attention. That is the order. On the left hand side, you have A goes before B. But on the right hand side, B goes before A. You can verify it by the sign of A and B. I give it for you to do as a homework, as exercise to verify it. It's very easy. Okay. Now we have the notion of symmetric, which is mặt trận đối xứng. Whenever saying about the symmetric matrix, we say only about square matrix. Mặt trận đối xứng chỉ nói về mặt trận vuông thôi ạ. A square matrix A will be called symmetric if and only if A equal A transpose. It means that when we change column into row, rows into column, nothing changes. So why is it? It is called symmetric because it is symmetric by the main diagonal. Or if you cannot imagine it, I can tell you that in Vietnamese, symmetric means đối xứng. By division, we write it A equal AT. But what does it mean? Đối xứng. It means đối xứng here means các entry đấy là đối xứng qua cái đường chéo chỉnh ấy. Thằng ở trên với thằng ở dưới bằng nhau, AEG ở trên phải bằng cái thằng AGE ở bên dưới. And here is an example. Suppose that A is given by that, and here we have the number, and here we have the letter, the parameter A, B, and C. Suppose that A is a symmetric, and you are required to find A and B and C. So in order to do that, first you write AT to be like that one. Then now, because A equal AT, you will get A equal 2, B equal 3, and C equal 5. It's here. And if you put it here, you will see A equal 2, B equal 3, and C equal 5. That is why symmetric by the main diagonal. Okay. Your homework, please help me to verify that given any matrix A, if you take A multiplied by AT, the first one, you take A and you take A transpose, you can always multiply A by A transpose. and the product is a symmetric. The product is a square matrix and it is a symmetric. That is your homework, please. And again, AD you can multiply to A and it is again a symmetric matrix. That is your homework. I will tell your teacher in the exercise class to verify. Now, in matrix multiplication, in general, we don't have AB equal BA. We have three possibilities for that. In order to consider that, first A is M by N matrix and B is N by P matrix. Then we have three following possibility. The first one is M and P is different. Then we can define AB, but we cannot multiply B by A. We cannot multiply B by A. So on here we have only the left hand side, we don't have the right hand side. Then you cannot have the equality there. The second situation, second possibility is the following. Even M equal P, but M and N are different. Then in that case, you can multiply B by A like that. But by definition, A multiplied by B will be of the side M by M. But B multiplied by A will be of the side N by N. Then AB and BA are matrices of the different sides. Because the M and N are different, so they are of different sides. Then they cannot equal each other. That is, in that case, we have AB is different from BA. And the last situation, the last possibility, that even in the case M equal N equal B, the size of matrix A and B is very special, so that we can multiply both sides. Even in that case, we have AB like here, BA is here. Two products are of the same size, but even in that case, AB and BA can be different from each other. Even that, the product can be different. And here is an example. You take A and B like that. Both matrices are of the size 2 by 2. And if we multiply them together, what do you get? A multiplied by B, you get that things. Very small matrix, so it is very easy for you to multiply. And B multiplied by A, you get that one. Obviously, the two products are different from each other. So you can conclude that AB is different from BA. So that is an example to show you, in general, the matrix multiplication does not have commutativity. Phép nhân mà trận không có tính chất ra ngoài. So in doing your calculation, please don't do commute two factor in matrix multiplication. Sau này khi làm bài tập, làm bài thi, cố gắng nhớ khi nhân mà trận đừng có đổi chỗ hai bên mà nguy ra. Cái đấy là sai nghiêm trọng. Now, that is it. cancellation law in Vietnamese is what? Cancellation law in Vietnamese luật rút gọn. Luật rút gọn. So what is it? Luật rút gọn. Luật rút gọn saying that if you have C number A, B, and C, and suppose that C is not zero, and suppose that the product AC equal B, C, then we can cancel C on the both sides if get A equal B. Chúng ta có thể rút gọn C ở hai bên để chúng ta nhận được A bằng B. So that is cancellation law. We are going to consider similar things for the matrix now. For the matrix, suppose that we have A multiplied by C equal B multiplied by C, and even suppose that C is not zero matrix, and in general we cannot imply that A equal B. That is, in that case we don't have a cancellation law. Với phép nguyên nhân ma trận như này chúng ta chưa có luật rút gọn ở đây. And only in the case C is invertible, then we can have A equal B. And if C is not invertible, then we can imply that then A is different from B, or we cannot imply that A equal B. In that case, we say cancellation is not valid. But however, here there is a new name, new word, that is invertible. Invertible is what we are going to define. But before defining it, I can explain to you the examples about that one. Suppose that we are given A, B, and C like that. None of matrix are zero matrix. But however, if you multiply A by C, you get that one. B by C, you get that one. The products are the same, but A and B are not the same. So that is an example to show you. In that case, cancellation law is not valid. Đây là ví dụ để cho thấy C không phải là ma trận không, nhưng chúng ta vẫn không có luật rút gọn. Chúng ta có A nhân C bằng B nhân C, không thể suy ra được A bằng B. Okay, here. Then, now is notion of invertible. And that is the last operation on matrix. Suppose that we are given a square matrix A. Yeah. If we of the order n, if we can find a matrix B, square matrix B of the same order, so that A multiplied by B equals B multiplied by A equals identity, then in that case we say A is invertible or non-singular. And if B, in that case we continue, we say B is an inverse of A. In Vietnamese we say A là ma trận khả nghịch, B là ma trận nghịch đảo của ma trận A. Sometimes I give you the name in Vietnamese that psychologically you feel it is easier for you to understand. But however, it is not so easy, not easier. Okay, now I have some more things to tell you. If a matrix does not have an inverse, it means that if we cannot find a matrix B satisfying that, then the matrix A will become non-invertible, ma trận không khả nghịch, or a singular matrix, ma trận kỳ dị. And in case we can find a matrix B satisfying that matrix B will be unique, duy nhất, chỉ có một hạng duy nhất. And because of that, the inverse of A, it exists, will be denoted by A to the power minus 1. Vì cái nghịch đảo tồn tại là duy nhất, cho nên ta luôn luôn ký hiệu nó là A lũy thừa trừ 1, A to the power minus 1. Then that equality now became that equality. Nothing new, just only replace B by A to the power minus 1. And here is an example. One of not so easy exercise for you. That is given a square matrix. How you can find the inverse of A. And here is an example. Suppose that you are given a square matrix A of size 3 by 3. You need to find A inverse. That is, you need to find a matrix of the same size like that, satisfying that one. If we multiply them together, you get the identity here. Now we consider C column of X by C1, C2, and C3. And we got C columns of identity by B1, B2, B3. Then, if we multiply the matrix on the left hand side, what you get? You will get the first one. You multiply the matrix, the first matrix to the first column, the matrix A to the first column C1. You get the first column B1 here. So that is the first equation, the first system of linear equation. And then if we multiply the matrix A by the second column here, you get that equation, and it must equal the B2, you get it here. And if you take A multiplied by the last column here, you will get the last column here. Then, in order to find the matrix X here, you need to solve three systems of linear equation. One system of linear equation is complicated enough for you, but now we have a three, and you have to solve all three. Oh, it is too complicated, too long. But however, if you pay attention to that, you see the coefficients are the same. C system of linear equation, but they have the same coefficient matrix. Now, if I write it in the matrix form, you have A C1 equal B1, A C2 equal B2, A C3 equal B3. C equation has the same matrix A. That is, we can solve three system of linear equation at the same time. Ba hệ phương trình này có chung một cái ma trận hệ số, vì thế chúng ta có thể giải ba cái phương trình này cùng lúc, không cần phải giải riêng từng hạng một. That is what we say. C system has the same coefficient matrix, means that we can use Gauss-Jordan elimination to solve them simultaneously at the same time. So that is what we are going to study after the break. So we have the break now, please.
Em cho anh mượn cái sạc nhá. Cho anh mượn sạc nhá để anh sạc điện thoại. I see.
tai si.
Thế này mà rách rồi, luôn đi, cháy này. Đâu đấy?
mẹ đến quán há miệng mà chưa quán thì sẽ lại để đâu có
Mấy con chó báo để vào đủ.
Chỉ giao hàng xong rồi tìm tiền.
Bây giờ nó tìm không? Bảo là cái máy phải thấy đâu tìm không? Tự nhiên không? Mày trước mày có bị mày bảo mày cáo đời vào đủ ăn phải đủ.
Dị ma túy. Chơi ma túy người làm sao? Em mua burger. Bánh mì. Hôm nay bánh mì không đi. Bánh mì bò ăn hồng hơn 3.000. Mẹ đâu. Cô các công đường về nhìn đâu.
Xem là cô luôn.
Đâu.
Đồng hơi căng nha. Một đồng một điếu có tiền.
once again, please, because now we are at the last hour of the morning, so not only you and also we are very tired, so I suggest that if any of you don't want to follow the class, you can get up, please. Because many of you asked me about that, so I explain to you that slide in Vietnamese. Cái này giải thích cho các bạn là muốn tìm ma trận nghịch đảo thì phải làm như thế nào. Ma trận nghịch đảo là cái mà chúng ta học ở cái slide trước. Đây, slide trước định nghĩa ma trận nghịch đảo là như này. Nếu một cái ma trận vuông A, nếu tìm thấy một ông B cũng vuông mà cùng kích thước như thế, sao cho khi nhân vào với nhau, nhân cả hai bên đều nhận được ma trận đơn vị. Nhớ ký hiệu IN là ma trận đơn vị, tức là cái ma trận đường chéo mà trên đường chéo tất cả vào một hết. Nếu tìm được như vậy thì A sẽ được gọi là ma trận khả nghịch, và cái ma trận tìm được ấy sẽ được ký hiệu của A mũ trừ 1 và gọi là nghịch đảo của ma trận A. Một trong những bài tập của các bạn sẽ xuất hiện thường xuyên là cho một ma trận A làm thế nào để tìm ma trận nghịch đảo. Thế thì đây là ví dụ. Cái slide tiếp theo là cái ví dụ giải thích cho các bạn. Nếu như tôi cho A là một cái ma trận vuông cỡ 3 x 3 như thế, thế thì muốn tìm ma trận nghịch đảo có nghĩa là chúng ta phải tìm một cái ma trận vuông như thế này, cùng cỡ, thỏa mãn điều kiện là đây, ma trận A nhân với cái ma trận x thì bằng ma trận đơn vị, ta gọi là như thế. Tất cả x11, x12, x13 cho đến x33 là những cái ẩn số mà chúng ta phải tìm. Tôi ký hiệu các cái cột của chúng. Đây, cột của ma trận x bởi C1, C2, C3, cột của cái ma trận đơn vị ký hiệu bởi B1, B2, B3. Thế thì nếu bây giờ tôi lấy A nhân với cái cột C1, nếu tôi lấy A nhân với cột C1 thì nó phải bằng cột B1, lấy A nhân cột C2 nó phải bằng cột B2, A nhân với cột C3 nó phải bằng cột B3. Đấy là định nghĩa phép nhân ma trận mà chúng ta học rồi, vừa mới học cuối buổi trước và vừa ôn lại đầu buổi này. Như vậy có nghĩa là chúng ta phải giải cùng một lúc 3 hệ phương trình đấy. Nếu như chúng ta viết nó lại thành phương trình ở dạng ma trận thì chúng ta có cái hệ phương trình sau. Khi viết lại cái này thì rất dễ nhận thấy rằng là cả 3 hệ phương trình này nó có chung một cái ma trận hệ số là A, và vì thế chúng ta có thể áp dụng phương pháp Gauss-Jordan để giải 3 hệ phương trình này cùng một lúc, và từ đó người ta mới đưa ra cái quy tắc sau đây. Các bạn cần phải nhớ. Đây là quy tắc dùng phương pháp Gauss-Jordan để tìm ma trận nghịch đảo. Phương pháp ấy được giải thích như sau ạ. So now I turn into English now. Now we can use Gauss-Jordan elimination to find the inverse of the matrix. Suppose that we are given a square matrix A. We need to find A inverse A to the power minus 1. How to do it? The first one, on the right hand side of A. On the right hand side of A, we write the identity matrix of the same sign, like that. Then we apply the Gauss-Jordan elimination to transform the matrix A into the identity. Then, with the same elimination, the same operation, the matrix I will become something, and something here is exactly the inverse of A. Tôi viết ông ma trận A này, bên phải của A tôi viết cái ma trận đơn vị cùng cỡ này. Xong rồi bây giờ tôi áp dụng các phép biến đổi sơ cấp về hàng để tôi biến cái ma trận A đấy thành ma trận đơn vị. Thế thì cùng các cái phép biến đổi xương khớp về hàng ấy nó sẽ biến cái phần ma trận đơn vị y kia thành một cái gì đó. Cái gì đó đấy chính là ma trận bình đẳng của A, chính là A trừ 1. And the example is here. Suppose that A to be that you are required to find A inverse. And if we do by solving the system of linear equation, we have the following. We need to find x1, 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 x2, x2, x1, x2 like that, satisfying that equation. And we multiply them together, we get that one. So from here you get two systems of linear equation. The first one is here. The first one means you have that equals that and that. So it's here. And if you pay attention to the coefficient, you see the two systems have the same coefficient matrix. And here you can apply that operation. That operation. You turn that coefficient matrix into that one. So that is the way we solve the first system of linear equation. Then our solution will be x11 equal minus 3 and x21 equal 1. And the same way to solve the second system of linear equation is here. And our solution is here. So if you take a look at that, you will see on the both sides, on the both lines here, we always apply the same operation. And we get that solution. And that is the way we find the inverse by solving the system of linear equation. Then x equals a minus 1 to be that. But however, if you do as I explained to you before, we can do it as follows. We write the coefficient which is here, and on the right hand side of A, we write identity. Now we apply the Gauss-Jordan elimination by that operation. Then A became that one, and that part of the matrix now became that one, and that one is exactly A minus 1. So that is what I explained to you in the previous slide. And here is an example to show you how we can do it. And always, because on the class I will give you only very simple examples for you to follow. And in exercise, at home, you need to do just a little more complicated exercise. In case the matrix A can be row reduced to identity matrix, then the matrix A must be singular or must be non-invertible. Nếu ma trận A mà không có thể biến đổi trở thành ma trận đơn vị thì A sẽ không phải là ma trận khẳng định. And here is another example, just a little more complicated. A to be like that, just a little big side. We need to find A inverse, so we follow the same way using the Gauss-Jordan elimination. We write on the right hand side of A, we write identity, and it is here. It is distinguished by dot vertical line. Now we apply that. We do it step by step. You get that one. So I will skip it for you to follow only. Then you see. And finally, you get that. That is already the identity. Then that one is exactly the A inverse. When the part A becomes identity, then the second part will be A inverse. That is, the matrix A is invertible and it has an inverse to be that one, and you can verify it here. So I leave it for you to verify by yourself. Now we define the power of the matrix. First, we consider that A to power 0 to be its identity. Chúng ta quy ước rằng A mũ 0 bằng ma trận đơn vị. That is only the convention. The second, A to the power k equals, you take A multiplied by A multiplied by A k times. Sometimes in the exercise you can find something like, please find A to the power 2022 of some matrix A. Then you should know how to do it. We have that property is very easy to verify, that A to the power A multiplied by A to the power S equals A to the power A plus S. That is quite similar to the operation on the number. Lũy thừa của ma trận, cái tính chất này rất giống tính chất lũy thừa của một số, không có gì khác hơn. Again, A to the power A and then the whole thing to the power S equals A to the power A times of S. And that property is easy for you to see. In case D is a diagonal matrix, then with the entry lying on the main diagonal is D1, D2, Dn. Then in that case, D to the power k to be that, on the entry will be taken to the power k. You can verify it by yourself. You multiply D by D and then you get D1 squared, D2 squared, C squared, and so on. Now is a property of inverse matrix. Property of inverse matrix. Suppose that A is an invertible matrix and K is a positive integer and C is a number, and I suppose that C is non-zero. Then A is invertible. Then the inverse of A to the power minus 1, again is an invertible, and the inverse of A to the power minus 1 is A. It is obviously from the definition. And if A is invertible, then A to the power k is also invertible, and the inverse of A to the power k equals that, equals A inverse multiplied by A inverse multiplied by A inverse, or we can write it by A to the power minus k. And C, now in that property I require that C is non-zero. In case C is non-zero, C multiplied by A is also an invertible matrix, and the inverse of that, inverse of CA will be 1 over C multiplied by A inverse. So we see at that time, at this formula, we have A inverse, but also we have 1 over C. That is the reason why we require that C is a non-zero number, because we need to divide it by the number C. And that property saying if A is invertible, then the transpose of A is invertible also. And its inverse is here. Inverse of transpose is transpose of inverse. And the last property looks like the property of transpose. That is, if A and B, both of them are invertible of the same sign, then the product A, B is again invertible, and inverse of AB equal B inverse multiplied by A inverse. Once again, in the formula here, I call your attention to the order of A and B. On the left hand side, A goes before B, but on the right hand side, B goes before A. So be careful with that. The order of A, B on both sides are different. Now we say in case C is invertible, then we have cancellation property on both sides, from the right and from the left. That is, if we have AC equal BC, then we can reduce C on both sides. We get A equal B. And if A equals CB, then we can reduce C on both sides. We get A equal B. That is, in case C is invertible, we can have cancellation law on both sides. The last one, the last property saying that has named Cramer's rule. Cramer's rule says that if A is invertible matrix, then the system of equation Ax equal B, which has unique solution given by x equal A minus 1 B. And we are going to coming back to that rule, Cramer's rule later, not right now. And sometimes we can write it, that property by property number 7 prime, saying that if A is a square matrix of order n, then we have the following statement equivalent to each other. The first one saying the matrix A is invertible. The second saying that the system Ax equal B has unique solution for any right hand side B. And the next one saying the homogeneous system of equation Ax equals 0 has only trivial solution. It has only 0 solution, nothing more. So that is the end of the lecture number 2, and we are going to begin the lecture number 3. So we continue right now. And if we look at If you take a look at the slide here, you will know why I need to begin it right now. Because the lecture is very, very long. Very long. The first lecture we have only 2 sections. The second lecture we have 3 sections. But now we have 5 sections. And any section here is very long one. So please. However, once again I tell you, it is easy. Here, that one is very easy. Believe me. First, this lecture we study what we call determinants of a matrix. Định thức của một ma trận. Whenever we say about the determinant of a matrix, only square matrix, chỉ có ma trận vuông thôi, không có cái gì khác à. Only square matrix. So the first one here, easiest way. That is the case of 2 by 2 matrix. Then in that case, the determinant of A will be defined by that 3. Yeah. Then determinant of A to be that. So very easy. So here is some notation. You can write 2 vertical lines on both sides of the matrix, like that one. And here is the examples for you. In case you have the number, it is here. And it is like that. So why I need to give you so very, very simple here. It takes your time because I want to tell you the determinant of a matrix is a number. It can be positive, it can be 0, and it can be negative. Định thức của một ma trận là một số này có thể dương, có thể không, có thể âm. I want to show you that only. Now I want to continue. The determinant of a matrix can be positive or 0 or negative. Now we begin with the difficult part of the lecture. Now we want to define determinant of any square matrix A. So suppose that we have a matrix A of side n by n. Then the first thing I want to tell you, that is the determinant of A is a number. Khi nào mà ai hỏi bạn định thức là gì, nói đây là một số, đừng có nói định thức là một cái bảng như thế này nhé. The determinant is a number. How we can define it? That will be defined inductively. Số đó được định nghĩa một cách quy nạp. Có nghĩa là định nghĩa từ từ. Okay, we inductively define it as follows. We define already for the smallest case, that is for 2 by 2 matrix. Now, suppose that we define determinant for any square matrix of side n minus 1 by n minus 1. Now A is a big one. A is big one like here. A is of side n by n. How we can define determinant of A? We can do as follows. First, we choose an entry Aij. We choose it here. And then we delete on Then we delete entirely the i's row, that is the row containing a, I, j. And then we delete entirely the j's columns. We delete that. So they left what? Còn lại cái gì ạ? They left a matrix of sign n-1 by n-1. Một ma trận cỡ n nhân n, bây giờ tôi xóa đi một hàng, xóa đi một cột, cái còn lại là một ma trận cỡ n-1 nhân n-1, đúng chưa? Mà cái đó thì chúng ta đã định nghĩa, giả sử là chúng ta đã định nghĩa định thức trước rồi. Okay, let's continue. They left only a matrix of sign n-1 by n-1. It is here. Here is after deleting the i's row and the j's row. And that we know already is n-1 by n-1. And then we know already the determinant of that, and we denote it by n-i-j. And we call it the minor of the entry a-i-j. Tiếng Việt gọi cái này là định thức con MIG hay định thức con của số h AIG. The MIJ is định thức con. And then we continue to define the cofactor of AIJ. Cofactor, we take the minor MIJ and multiply by -1 to the power I plus j. The Cij in Vietnamese seems phần phụ đại số or something. If you take a look in the Vietnamese textbook, it calls it phần phụ đại số or something. So we have Mij, the minor. Cofactor is Cij. And once again, I would like to ask you, remember, the minor is a number. The cofactor is again a number. Định thức con cũng là số, phân phụ đại số cũng là số. Now, here is some examples. For A to be like that, then what is M21 to be that? C21 to be that? So sorry. Okay.
Bây giờ mình cầm thì bao giờ mình lên? Bây giờ mình cầm sẵn.
Đau thế. Trong việc gì cũng phần trăm đột kiếm là chạm một chạm. chỗ. Sao?
Cày vậy.
Điều gì tốt?
Vì vậy
Thì nó thua luôn.
Chắc là